Welcome, everyone. This is the first and inaugural show of our What Works series, where we're bringing you practical advice from our consultants who I've been working with for a number of years. We're going to do these sessions every Friday for the next month or so, 1 p.m. Eastern time. So I hope you can join us for all of them or whichever ones are most appropriate for your environment. So these are the folks participating in the series. Today, we're going to be talking with Carlos Bossy, our senior architect and designer. Next week, it's Sean Hewitt. It's going to be talking about data governance. Then Josh Reed on data literacy. And then I'm going to switch sides in this conversation. And I'll be talking about data products, data fabric, generative AI, and under the rubric of self-service. And then we'll finish up with Rich Fox, who's our CDO, CDAO, is going to talk about how to put the business first. So that's our lineup. So we hope to see you every week. We will be recording these. So if you miss one, you can always tune in later. Okay, so just a little bit about Eckerson Group. I think a lot of folks know us from our research, our white papers, our reports, our blogs, but we also are a consulting organization that we do project consulting with a variety of companies. And our consultants, as you saw from the picture, we're all pretty veteran. And we've been doing data and analytics for 20 plus years. Carlos and I probably closer to 30. So a lot of experience. We've seen a lot of things, and we think we can provide a lot of help to you and your organization. So these are our focus areas when we go in and do project-based consulting. And this is our team that provides consulting in these areas. And some of the clients that we've had recently are listed here. You can see brand name, not brand name, small, big, medium size. So we've been across multiple industries and regions, Canada, Europe. So we have a very active consulting organization, and we hope that you take advantage of our expertise and knowledge at some point. And feel free at any time to send me an email if you want more information, wayne@eckerson.com. All right, so let's start. So as I mentioned, Carlos Bossy is our featured consultant today. He's got more than 30 years of experience in data architecture, data modeling, and analytics architecture. Interestingly, he was contacted by Microsoft to architect its Office 365 data warehouse. He's often referred by the Kimball Group for complex data warehousing projects. And just some of the clients he's had recently, National Interagency Fire Center. We're actually working that one right now. Arizona Healthcare Cost Containment System, Connect for Health Colorado, University of Arizona, South Metro Fire and Rescue, Departments of Human Services in Washington, Oregon. The list goes on. So he's been out there doing this a long time. So very eager to hear how he synthesized best practices in data architecture. So with that, I'm going to turn it over to you, Carlos, to talk about your first couple slides here. So I think you're going to start from the end, right, and talk about key takeaways.
I am. Thanks a lot, Wayne, and thanks everyone for being here. There's a lot of content here, and so getting through it in less than an hour it's a lot to talk about. So what I want to really lay the foundation for here is what the session is about and what you should get from it. And the first takeaway is going to be how do you get more value from your data quickly, which is what everybody is asking for and looking for these days. If they get any value from the data, it's slow, and a lot of organizations haven't even figured out how to do that yet. So hopefully that's one thing we do today is figure that one out. We're also going to talk about how to build it right and why building it right makes everything better. And I put right in quotes because, what does that mean? Well, what we do here is a little bit more of an art than a science sometimes, and it could be different for different organizations. But, when we talk about anything to do with data, it has to do with engineering, deployment, new features, ad hoc analysis, modifications, dashboard development. How do we do all those things, do it the right way so we can do it better, get more value, do it faster? And one of the things we also will make a good point of is in our experience, these projects don't work with what we call the Big Bang effect or the Big Bang effort. We need to grow into solutions. For years ago and traditionally, and even now, some companies and organizations still want to design everything and architect everything up front, document all requirements before they build anything, and then build it. And those projects are typically not successful. And in today's world, it's much easier to grow into solutions working the way we work today and working in the cloud. And we'll talk a lot about that. And because of that, we always recommend designing iteratively in an iterative fashion, and always start with 2 to 3 MVP use cases. That way you can develop a good foundation and learn a lot, and then go from there and continue to develop that way. So in the end, why are we doing this? Well, what I like to tell people is the reason we do this is we build good architecture so you can get the data you need when you want it, the way you want to see it. And that's not an easy thing. It sounds it's easy said, but it's easier said than done. But we're trying to really minimize that resistance in data usage that people experience today. And how can we do this? And I always tell people we see a lot of organizations struggle, and so there's a lot of ways to do it the wrong way. There's a few usually pretty good choices, and usually 1 or 2 better choices, but often there isn't a best choice for everybody. There's always trade-offs and different solutions, different techniques. There's no magic wand you can wave and it'll work. So in the end, we try to make the best choices we can and build the best architectures we can based on what we know.
Yeah, that's great, Carlos. I've heard you say these things numerous times, and it's interesting. One recent client had contracted us to design a data architecture. Now, typically, if we're doing a data strategy, we'll do a conceptual architecture and maybe a logical architecture. But this is a large federal agency, and they wanted this like tome, a huge document that defined the data architecture. And, we were all it was going to take months, right? And we knew that the output was just going to be, a pile of paper that gathered dust in the corner. No one would implement it, and may not even be relevant by the time we produced it, right? So you convinced them to do this number 4 here on this list, let's design a conceptual architecture and then pick 3 high-value use cases that we can deliver in 8 to 12 weeks to flesh out different parts of that architecture and see if they actually work using the tools that were selected. And they jumped on that and they loved it. And here's a government agency that is building something for thousands of other agencies to use, and it seems to be going extremely well. And I think I've been a convert to this approach, this iterative approach. And I'm curious why not everyone uses that approach.
Yeah, I think people are afraid of going into a big effort without knowing all the answers, right? I think they feel they need to have requirements from every part of the organization and make sure they've analyzed every situation that may exist in the organization that's a pain point, and are uncomfortable going into a project without knowing all the answers all the answers to those things and all the requirements before they start. And what I like to tell people is that, if you start off and you develop things, again, the right way, quote unquote, the right way, you model things properly, you build transformations properly, and you deliver data the way people want to see it, you don't have to know everything up front. You don't have to throw anything away. You can build on top of what you did. So I think what we try to do is remove that fear of not knowing everything before you start. And at the same time, when you do gather those requirements and put those strategies together and build a big document out of it, we're asking people to look into the future and see what they might need 2 to 3 years from now. And most business people, that's just not their way of thinking. We're asking them to be visionaries, and they're just not able to do that.
Yeah, no, exactly. Yeah, well, let's move on, but I don't see any questions in the Q&A tab yet, folks. So this session's for you. So if you have any, there's one. Christy asks, is an 8 to 12 week MVP possible if we don't already have the tools chosen? Well, I think you need the tools chosen.
Yeah, I think I would probably eliminate, yeah, not eliminate, but put tool selection outside of that
That's sprint
8 to
zero,
12
right?
week sprint. Yeah, that would be sprint zero is
Yeah,
what we like
we
to
were
call
talking
it,
about
right?
sprint zeros the other day.
On the other hand, in an 8 to 12 week sprint or in an 8 to 12 week effort, I would also use that to prove that the tools are the right ones. It's an MVP, and it's something that allows you to swap a tool out. You don't invest too much into it before you get to a point where you decide it's maybe not the right tool. But yeah,
Is it more
let's yeah, go ahead, we.
is it more likely you'll swap out a tool than swap out a design element?
Yeah, probably. I think I would say if it's a new effort, let's say it's the first time you're actually building in the cloud, for example, and all the tools are new to you. I think there's a chance you may swap out a tool in those scenarios.
Yeah. All right. C Dove asks, what are the specific types of arguments used to convince C-level customers to shift to iterative approach like we're talking about here? Yeah, with one of our clients, that it wasn't hard at all. She jumped right on it, and
Yeah,
it's
I think that client was because they'd failed so many times before, right?
yeah,
They'd spent 10 years talking about this. They'd already brought in other consulting companies, put strategies together, but they never had anything they could take action on. So
yeah,
one of the convincing arguments is that, hey, we've done this before, we've talked about it, but we haven't actually built anything. And the other argument in my mind is that I can give you value in 12 weeks or less. And that's pretty compelling because a lot of these projects have burned a lot of executives in the past because it's a 2 year project and after 2 years it's still not working right. If I can show them value in 12 weeks, they might buy into it and then they're into it for the longer term.
yeah, and that's just what happened with our more recent client, right? We showed the MVPs to a lot of their stakeholders, and they're like, their mouths dropped open. They
Yeah,
couldn't
yeah, you get
believe it.
people excited, right? You show them how quickly you can do something and put something out there and they get excited and then they want more.
Yeah, yeah. All right, Jay asks, how do you balance the flexibility of iterating with the risk of going down a path that needs to be scrapped and redone when new requirements surface? Well, I think you kind of answered this already, but
Yeah, I'm a big believer in if you start off building an architecture, knowing, and we'll talk a little bit more about this later in the session, but knowing how data is going to be consumed and modeling it properly for that consumption and transforming the data in proper places so that it's delivered to them in that form, you really never have to throw anything away. You might zigzag a little bit, but if you build something good, a good foundation, you have to have the confidence that you're not going to throw it away.
yeah. All right, let's talk about how to do it the right way, the good way, right? I think that's what people probably want to know now, but I think we want to kind of go through these mistakes to set up the guiding principles, but we have 10 mistakes with a bonus here. But so why don't you go through these pretty quickly? In fact, I think I'll just put them all out here for you.
Yeah, so this comes from, a lot of work that Wayne and I have done together and the team with a lot of different organizations, government and private organizations, any type of organization. And we see a lot of things repeat themselves over and over. Number one, that makes there's no data model or the data model is inflexible, right? That's one of the key mistakes that people have made, and that comes from years ago where people were trying sometimes to create a single version of the truth, for example, making the data model inflexible. Or a backlash to that was don't build a data model at all. So there's kind of both ends of it that made it difficult for people. No zone-based processing. We talk about zones, data zones, different types of data, the same data, but the data is formatted or modeled differently in each zone for different purposes. And that actually we find helps people a lot in their journey as they use data. They get, again, the data how they need it. If they need it more analytically, they get it. And if they need it more raw, they get it, or somewhere in between. The data models don't support a wide range of use. Again, this goes back to that single version of the truth or the one data model that will solve all problems. again, in today's world, we understand that data is modeled differently for different purposes. Data scientists need different data sets than data analysts, than data engineers and business analysts. So we try to provide it the way they need it.
So that's interesting because you're saying that there is no one universal model anymore. So like a warehouse might have multiple models,
Mhm.
but we've seen a lot of examples of warehouses that were, they're basically dumps of report data, right? And so they have these kind of like little silos modeled for each report. So you're not talking about that kind of diverse modeling, right? The
I'm
models
not.
do all hang together, right?
Yeah, yeah. Yeah, I think in fact most of the data modeling concepts that we've learned over the last 20 or 30 years, dimensional modeling, data vault modeling, or third normal form modeling, anything that might be helpful is still useful in what we're doing. What we're really just saying here is the same model doesn't support everything,
Yeah.
appropriately.
But the model should be integrated or
That's
conform. Yeah.
that's right.
Okay.
Right.
Let me put three more up here.
The wrong people in the wrong roles. I think as an architect, you often see people with, an architecture title trying to, struggle through building out an architecture, that they really haven't had the training or the mentorship to do it. There's also often people managing roles that are important on the data side of things that but they're maybe not savvy in those particular areas. They're managing a bunch of data engineers, but they're not really they don't have a lot of data engineering expertise or that sort of thing. Or often a data analyst is doing much more of the data crunching and transformation work than the engineers are doing. So we see a lot of those things. Organizations, I think again are having a very difficult time keeping up with what's happening in the world of data, and that's why we see those things. No governance and oversight. I think I'll talk about oversight a little bit more than governance, but there will be sessions on governance in the next couple of weeks. But when I talk about oversight, I'm really talking about architectural oversight. I make decisions as an architect as to how we'll do things. I need to make sure that we're rigorous about how those decisions, how that architecture is implemented. And I think in a lot of cases it's very loose out there, and there isn't much oversight, and there's people that have a misunderstanding of how they need to use the architecture. So some people are just trying to get their job done. And then no data sharing. This is a big one today, especially with so much data and decentralization of data. Data sharing, if it's happening on an FTP site where people are dumping data in there, and that's usually out of control and not useful anymore. So there's modern data sharing concepts that we try to implement with people that I think work a lot better today.
Yeah, just a note on the research side of our business, we are tracking this emerging technology that we're calling data sharing platforms, and they're kind of like data marketplaces for internal consumption. Very exciting area, dovetails with the whole notion of data products and things. We think this is going to be really big in the next 2-3 years.
Number seven, that's actually something we see sometimes. A company built a good architecture for their application, their app dev team. It works really well. They built it on modern principles, microservices, that kind of thing. A lot of those techniques aren't really appropriate for large scale analytics and large scale aggregations of data and things like that. So well, some of the things we can, and we'll talk about that later too, we can borrow from the application side of things, and they're ahead of us in some ways. There are also some techniques that just aren't appropriate. We've seen people try to do everything through microservices and through APIs and that sort of thing that might limit how somebody on the data side can use the data properly.
You know where we see this mistake most often, Carlos, is with SaaS companies that we work with. Especially the startups. They've hired a bunch of software engineers to build out their product, and then they assign some of them to like run the data side of the application or even internally. And yeah, they try to do things like it's all object-oriented code, and it doesn't quite fit. And there was once when we actually gave them some data engineers to work with their engineers to kind of implement an architecture we had designed for them. And they were just two different cultures, and they clashed, and it just didn't work out because they weren't going to retrain themselves on data engineering concepts, you know?
That's right. That's right. They're very software engineering centric, right? Would be
Yeah,
the way to put it. So,
yeah.
and that's what they know, and that's how they try to work. And master data is not formally implemented. This isn't new. I think we could have said this 20 years ago, and a lot of companies out there are wanting and knowing they need master data, but just have had a difficult time getting to where they need to get to with master data. Data environment is not future proof. They build things that they can't grow into. They're limited by certain things, certain products they use. Maybe they're not ready to go to certain environments or products in the cloud that allow them to expand.
Yeah, I think I changed the wording here a little bit on you, Carlos,
Oh,
but
okay.
you had like not adaptable, not flexible. So, but I think
Right.
you basically described what I was calling future proofing because it was shorter.
Yeah, that's fine. That's fine.
Yeah, I mean your architecture has to adjust and adapt, and if it's inflexible, that's when it becomes a bottleneck, right? Because it becomes really hard to change it and time consuming and expensive,
Mhm.
and then people just try to avoid working with you altogether. I think we've all been there in one situation or another. All right, last two.
Yeah, and number 10 is an important one. We often hear about somebody thinking that if they buy a new tool or move to a new product, it will solve all their problems. And, that's just not true, right? And there's a lot of good tools out there. A lot of them can be made to work very well, but you can also break any of them in 10 minutes, right? If you use them wrong or set them up wrong, or they're not used for the right purpose in the right way. So going to a different tool, if let's say you have a really poor data model and people are and dirty data and people are having difficulty reporting, going to a different reporting tool just isn't going to fix that problem. But we often hear this as like we say here, as a silver bullet. And then the last one is there's a lot of cases where SQL knowledge is required for ad hoc analysis, and that's kind of become a default thing. It's almost like everybody in some organizations, everybody has to know SQL. And what we're trying to do here is build architectures again to give you the data you need how you need it. And if SQL is not your thing, and you're not gonna, or you have to go to somebody who knows SQL, that you should be able to analyze your data without that knowledge, right? You shouldn't have knowledge not only of SQL but of all the database relationships and tables and things like that to do any analysis.
It's interesting. We spent 20 years moving towards graphical user interfaces for developing BI and data solutions, and now we're going backwards. Seems like everyone wants to code in SQL or Python or R.
Yeah,
Oh,
that's
and
right.
for better or for worse, I think sometimes for worse. But I think you're right. I mean, we've always made it too hard to go get data. Like, you have to go to a data warehouse, and now you have to know SQL. And I always think, well, we don't go shopping at a warehouse, although I guess Costco and things are kind of like that and Home Depot, but it's not a pleasant experience, right? You really want to go to a boutique store where you get a lot of help and everything you need is right there. So I think the goal of these modern architectures is, as Carlos said, to make it easy to get what you want, how you want it, when you want it, without having to learn a new skill necessarily. But we make that too hard. So I don't see any more questions, folks. So send them in and we will address them. Carlos, are there any other mistakes? Because you had 20 here and I picked 11. Is there any we missed?
No, I think it's well covered here. I mean, I think
Okay.
there's obviously a lot of one-off mistakes. I think these mistakes are ones we just tend to see over and over
Yeah,
again
we
a
do.
lot.
We definitely do. All right, so let's get into the flip side here, which are the guiding principles. We're going to go through each one of these, but do you want to just go right into them, Carlos?
Yeah, I can give a quick overview here on this slide, right?
Okay.
The things I'm going to talk about here is the eight guiding principles is there needs to be strong architecture oversight. We need to have data models appropriate for the usage of the data. We need to have change management techniques, and change management is so that we should be able to make changes fast, right? And that's, I think, a big complaint that a lot of companies have is our data people or our data engineers, they can't keep up with us, can't make changes fast. We should provide sandboxes, places where discovery and analysis can be done independent of anything else going on in the organization. We should provide appropriate work environments, sharing data, publishing data, those kind of things that analysts should be able to do. We talked about zones of data. We should transform data and put it in zones of data so people know what they're seeing and how they're using the data and what it's intended to be used for. And the zones describe the intent. We should be able to build in an agile way. And again, things that we can learn from our application developers and our counterparts there is that the data side can also be agile and can also work in sprints and deliver quickly. And then we also can learn from them better dataops and quality initiatives. The DevOps side of on the application side is pretty far ahead of us.
Okay, from an anonymous attendee, what are the features, characteristics of a good data model? It's a simple but tough question.
It's a tough question, but the way I would describe a good data model is that when I, as a business user, and I could be anybody in an organization, I could be in the field, I could be a business in an office, I could be in finance, I could be in manufacturing, and when I go get data, and I need data and I use it, it looks like I want it to look, right? That's really the feature. I don't actually have to do anything to it to make it look like I need it. It's delivered to me in the way I need it to be. So the data model gives me the data the way I want it to be.
So that's from the user perspective. What about from the developer, the person who's designing the model?
Well, I mean, the person, when we're designing the model, it's all about, in my mind, whatever model you choose to produce for that persona, to be rigorous about that model, to make sure that you follow the concepts of the model, the reasons for building a model, you follow it properly. For example, we see a lot of star schemas out there, and star schema became very ubiquitous, through the years, and yet the reason they don't work well for a lot of people is because they're not following the modeling principles precisely. And so the star schemas break, they tend to be difficult to use, they're slow. So for example, the reason I build a star schema is so that it's easy and it's fast. And I can, I'm able to pivot data as a financial analyst very easily in the star schema. But if I have to think about how the data is modeled there, then that means I probably didn't model it correctly, right? So it's really about following the concepts of building a star schema properly, or of building any other type of model properly.
All right, Derek says, are there standards for architectural data flow documentation that you recommend as minimum best practices?
Yeah, that's one I'm actually not really addressing in this presentation, but I think in general, a lot of diagrams, right? We tend to do it through diagramming, not through verbiage or anything like that. And the key part about data pipelines and data flow is, where does the transformation occur? And then where do the quality checks occur? And what happens when quality checks fail? I think those are the key parts. And so we build out a lot of our documentation tends to be mostly just diagrams in those cases.
Yeah, and we have a bunch of Carlos's diagrams at the end here that we'll show you. But I guess there's two places where you can get written documentation. I think, Gen AI has the capability to create that for us, I think. You correct me if I'm wrong, Carlos, if you know. And then there's certain class of tools, the data warehouse automation tools, do that automatically as well. Any thoughts on those?
No, that's true. I mean, I think all those things can help today, especially. I think with some of the things we can generate automatically from the tools and from third-party tools, I just don't have like a good recommendation on go to this particular tool and use it this way. I think in that sense, if that's kind of the question too. But I think in general, we've always, again, not done a good job of documenting a lot of what we do and a lot of how the data flows, and it can get very complex. And so, I think any tool that can help you, either built into your products that you already own or third party, are certainly viable.
Have you ever, I don't think I've heard you talk about using a data warehouse automation tool like Time Extender or Warescape, or you're not a fan of those, right?
No, not really. I mean, I can't say I've used them. I have consulted for a few companies years ago that went down that path. Again, trying to, have the code automatically built to target a particular model. But I've never been a big fan of those. I guess in my mind, for simpler cases, I think, and where you don't have a big staff, they might be viable. I think though, if you throw most situations that we see out there where the organization is very complex, very big, it would be difficult to I think use a tool like that. Although again, not completely up to speed on the automation tools today.
Yeah. Okay, Ram, I think you answered this one. Given everything with software engineering, DevOps, ML ops, data ops, all the ops, right? How
Yeah,
do you
yeah.
differentiate between data engineering, software engineering? I think data engineering teams still have to embrace software engineering practice. Absolutely. We've written a lot on the research side about data ops and CI/CD and orchestration and test management and monitoring and things like that that are part of data ops that was borrowed from the whole software engineering sphere. Those are great best practices, agile and debriefings. Yeah, there's a lot, as Carl said, a lot of practices from the software engineering world that we want to adopt. And certain types of data platforms like Snowflake with its zero copy cloning, we can almost start to treat data like it's code, right?
Mhm.
Which is kind of an interesting new development. And so it becomes much easier to manage it in a software engineering way.
Yeah, I mean, just to start with, for example, all our code should be managed and checked in and versioned, right? And can we say we really do that on the data side? We probably don't. How many times does a data analyst produce a SQL statement? It produces the output they want. They put that into an Excel spreadsheet or a CSV file and then send it out somewhere. That's a production process, right? They built production code, and yet that code is not managed the way we'd like to manage it, right? And then that code's not retested when things change in the system. So those practices are obviously all things we should be doing and would love to do on the data side, where we're just behind on those practices.
Here's a good question from an anonymous attendee. Is it best to have an architect designated role to do the design and modeling, or can it be folded into another role? Principal engineer, data modeler, for instance. I encounter a lot of, quote, we don't need a sticking architect attitude. I think I know what you're going to say here, Carlos, but I'll let you go.
Well, I mean, I guess I don't know if I care that much about the title or the labels, right? It's, are you building good data models, right? And if it's somebody who's a senior data engineer and they're producing really good data models, you don't need to have that role. And data engineers, even with a good architect, data engineers always do some data modeling because some of it is smaller or a little more trivial and they have input in that area. But or sometimes they present a data model up to the architect and kind of discuss it and get it approved. But essentially, I mean, whatever gets a good data model out there is fine. We just see a lot of data engineers. They're set, again, they're behind. There's a big backlog. They're in a hurry, and often they don't spend time to model the data properly, or maybe they don't have the expertise. But whatever gets it done, I mean, you don't have to have the title or the person. Yeah.
Yeah, good. Christy asks, we are a small, mid-sized organization currently with a very traditional data architecture. I don't want to do Big Bang. Where do I start?
Again, I guess we talk about this later, and we might not get to it at this point, but typically when Wayne and I work on with a client, we can identify 30 or 40 use cases that they need uh, uh, to have some kind of solution for. Then at that point, we pick two or three that are the most high value use cases that can be done quickly. And then from that point, pick one or two and start there. I mean, and you probably don't need somebody to come in and tell you what those use cases are. In your situation, you probably know what they are. Pick a high value use case that you think you can deliver in a short period of time, and start there. If it's all unfamiliar to you, go with what you know. Ideally go into the cloud because it's easier, faster. You can provision services as you need. You don't need to make all the decisions about licensing ahead of time like you did on-prem, and then start to work on something like that. While building it with good practices.
So, Carlos, we have a lot of good questions coming in, but why don't we move on for the moment, and we'll come back to these.
Okay, sure.
And yeah, so let's go to your first one, oversight. Maybe we can just speed through these a little bit because you've addressed.
I mean, really, I want oversight to be lightweight. The architect should not should not hinder the process. Most changes, I say more than 80% of them should be obvious, right? We should agree we're going to make this change. Let's move forward. There doesn't have to be a big committee getting together. It needs to be very collaborative with our engineers and analysts. And what we really want to do is make data readily available, right? We don't want to be a roadblock. We want the things that should be part of this oversight process is, where is data stored and in what zone is it stored? How is it modeled? Where is it being transformed into that model? And what tools are we using for it?
So the big sin that you and I see most often is that people have no oversight. It's
That's right.
Not even like heavyweight. It's just doesn't exist. And very quickly, the architecture gets way out of control.
That's right.
All right. Let's keep moving. Why don't we go through all of these quickly, and then we'll come back to answer the rest of the questions. So folks, put your questions in. We'll get to them.
Okay. I talked about data modeling already. We like to implement zones of data. The zone will have one or more different data models in that zone, sometimes one, sometimes multiple data models. And then that way it's well known. When I use that zone, I'm also using this type of data model, or I'm populating this type of data model. And the same data can be in multiple zones and in multiple data models. And, we're in a world today where we can duplicate data and have it look different for different people, and we should do that. We also need to make sure all data is available in the raw zone, that all the raw data is always maintained as is before it's cleansed or transformed. And I think if you do that, you cover all your bases.
Yeah, we'll show some diagrams at the end of some of his conceptual diagrams.
Change management, again, make changes easily and fast. Again, if you're not in the cloud, this is made much easier by being in the cloud. Wayne talked about being able to clone databases, being able to do things. We can spin compute up and down easily. We can get storage a lot easier. So generally speaking, what we want to be able to do is set up an environment where I can move something into a production system and yet not impact or break my existing production system. And in today's world, there's certainly different techniques to do this, but that should all be available to you. This is about having work areas where people can work and have enough compute power and storage power to do their work, but not impact the rest of the environments, right? Not impact source systems or the data warehouse or the refined data or anything else. And so provide sandboxes, again, that can be spun up and down, that can be flexible. The sandbox is really about a data analyst or a data scientist doing their work there and trying to do just true discovery work. And in the end, hopefully coming up with something that later on can be turned into a production system. Work environments, make sure that everybody has the right work environment, and we work in good environments. We always want to be working towards proven engineering principles. And I think we talked about all those already, like all the DevOps principles and version control and things like that. If we can get to those types of environments, it'll make everything a lot easier and faster. And on the data side, we want to be able to, when I'm producing or consuming data, we want to have the right tools to share data and other processes, right? So that if somebody else in my organization did really good work, I can actually benefit from it. If I'm in finance and they're in marketing, they can share what they did with me very easily. And that's a work environment. Wayne talked about data marketplace and data products and things like that. And those are the types of tools that we think most organizations need today.
Yep.
This is about the data zones and having different types of data zones. This is an example of going from source data to the raw zone, refining the data, going to the analytic zone, sharing or labeling data as trusted, and then having it be used by a user. And an example of what happens at each point in time. Raw data, it's untransformed, it's uncleansed, but it's organized. I want to be able to use it and find things if I need it. Refined data is transformed, it's cleansed, and it ends up being foundational. Sometimes I like to call it master data, not master reference data that we manage, but master data that we're creating. Like we might create a product master or a client master table in a refined zone. And that client master data may have come from many, many different places and source systems, but it ends up being the master table that the whole organization relies on. So it becomes foundational for other things. It can also be done for compliance purposes and for legal reasons that we need to build that data in the refined zone so that we always use the right data when we're going forward. The analytic zone is typically modeled. It's made to be simple and fast. And often what we think of the analytic zone might be our traditional dimensional models, star schemas, that kind of thing. Things that can be done, can be turned into pivot tables, data that can be pivoted easily, it can be fast. If it's modeled right, it should be easy and fast. And then there's the shared data or trusted data. And any of the data in these zones, whether it's raw, refined, or analytic, can ultimately turn out to be data that I want to share with somebody else. And if I'm sharing it, there should be probably a governance process that says this data is trusted, let's publish it out to the rest of the business. Other people in my business maybe can subscribe to that data. They might get regular updates of that data, and that's a way for people that are doing good work in other places for me to benefit from it. On the user side, the data should be very interactive, and it can be augmented there to support the context of the user's context, whatever context they're working in. Sometimes a user may have a certain measure or metric that can only be determined at their level. And so they need to have the ability to produce those measures or metrics that maybe aren't baked into the process up to that point. So there's a transformation happening at every point in the process. And one of the keys here is just make sure it happens in the right place for the right people.
So just to clarify on the user zone, when you say augmented, that what you're really talking about there is building a metric in a BI tool that's localized, not in the enterprise data environment that's usable and accessible by all.
That's true. It could be in the BI tool. It could be in Excel, right? It could be somewhere along those lines.
And the shared trusted zone, that's not exclusively a data marketplace or data sharing platform, right? Because sometimes because sometimes you have a trusted zone. I know we've had trusted zones in the warehouse or the data platform.
Yeah. I would say it's even just sometimes more of a label, right, than a physical, thing. Sometimes it can be, but it's at some point something new gets created. We need to call it trusted, and we need to by calling it trusted, it can be shared with other people that have access to that. And how you share it could be quite different. It may be that you use it through a BI tool as well.
Yeah. Okay, let's keep moving here. Two more.
And we talked about this already, agile sprints. A big believer that, again, really good data architecture can be developed in short iterations. We talk here about, there's some details here that you can read through, but we talk about what happens at each part of the process. We talk about identifying use cases and MVPs, iterating through them, deploying them. On the left-hand side, you see that typically what we can do is identify potential use cases, and usually it's about 30 to 40, and maybe whittle that down to 3 to 5 candidates for development, then choose 1 or 2 from there. But make sure you use use cases that will test part of what you need to validate. Let's say you're interested in a data catalog. Well, make sure that you pick a use case early on in the process that proves out the data catalog product and the process that you're putting together. Or you need data sharing in a big way, so you pick the right process so that you prove that out early in the process. And then the last one is, again, data ops and data quality. And this is about everything we can say about DevOps and managing engineering projects, automating, monitoring, iterative testing, being able to reproduce things. In the bottom right, I say they're adopt proven app dev processes and practices. And that's really what we're trying to say here is,
Yeah.
we're a little behind in this case. So the more we can adopt some of the things our partners on the app dev side have done, let's do that.
All right, so we're going to show a few diagrams here. I think we'll just show them, Carlos, unless
Okay.
you have some really urgent comments to make, and then we'll get right to the questions that I think people are eager to ask. So
Yeah, I don't have much to say here except that, these diagrams are done based on, not every architecture is the same. There's certainly overlaps and similarities. In this case, we have the data marketplace process going up there in the top right-hand side, which was, I think, we felt a key component of this architecture early on. But you see the various zones and, even a real-time delivery zone that we haven't talked about earlier. But that it's a very specific architecture for this particular agency.
yep.
We don't need to spend much time on this. This was one use case for that agency and how it makes use of that architecture. But it's to show that it's not going to make use of all the architecture, right? And again, the use case doesn't have to make use of all the architecture, but it did do two things. It produced a dashboard and it used the data marketplace. And those were two key elements that we needed to do early on. And this is another architecture that was, this was a company that what I would describe had a spider web effect, where every piece of data went in every direction possible in their unarchitected architecture on-prem. And, we put this together to have a little bit more, again, determine the zones of data and where ETL and master data processes would happen. We also put a data services layer around there because they also had a need for being able to get data at any time, anywhere, or at least wanted that. So the data services layer concept allows them to do that, and it's basically all the way around, so it can go pretty much anywhere. And then we also put that virtualization federation layer in there. If needed, that would be a way for them to also be able to get data from anywhere they needed at any time.
Yeah, so Carlos and I had long debates about the data virtualization. I'm a big believer in that for self-service ad hoc access. If it's the right kind of tool with discovery built into it, basically a data catalog built into the front end of the data virtualization tool. I think it's a key tool in any architecture, but I know from an architecture perspective, Carlos has some questions about whether those tools can really provide a universal services layer, which is interesting. I hadn't seen this version of it because you have both a virtualization layer and a data services layer. And I would have put the two together, but you obviously have them separated for some reason.
Well, in this case, I think it was because of the client in particular they already had a virtualization product that they could use and wanted to make use of, but wanted to also build a data services layer. So it's really more of a visual for them to show you can keep your virtualization product, but also build something else to help.
All right, one more diagram.
And then this one is actually a little bit more of a physical architecture about how a client is using Azure, I think in this case, to move data through. And one of the things I just wanted to specify is, they're using the bronze, silver, gold concept here in their labels in the middle, which is fine. It's essentially a lot of what we talk about. Bronze is raw data, silver is refined data, gold is analytic data. I think the silver part of it is probably the most important part in that it can be many different things. It can be master data, it can be other things, foundational data. But one of the things that was interesting here is that you see that in the silver layer, they're modeling as the data model is a data vault model. So they're deciding that everything, to them, refined data will all be modeled as a data vault model. So if you're familiar with the data vault model, it's a very precise way of modeling data with hubs and satellites and link tables, and has a very well-defined methodology. And I wouldn't necessarily suggest it for everybody, but if you have expertise in that area, that's one of the options of how to model refined data.
Okay. This is a chart that a lot of our clients love this chart, and so we tend to use it over and over again. And I think, Carlos, you're saying this is a great way to lay out kind of the problems, impacts, and solutions to your architecture, right?
Yeah, this is a good one to show. Well, it consolidates all your problems into like one slide, but it also shows why it's hurting you and then what you need to do about it. And I think it's a really good chart to show executives as well, right? This is
Yeah,
you whittle a lot of this information down to this, and you tell executives this is what we need to do to fix our problems.
yeah. All right, so let's see. We're doing a time check here. So we got 3 minutes till the end. But Carlos, do you have time to go over? Because
I do.
we got
I
a
can
lot of
stay
good
on.
questions, and I'd say we just stay here and answer these questions until we're done. And by the way, I didn't mention up the front, there's no sponsor to this webinar. That's probably unusual out there these days. So you won't be contacted by anyone. In fact, we'll probably be the ones contacting you to send you the slides and stuff like that. And we would appreciate if you like this session to spread the word. I think there's been a lot of valuable information that comes out of it, and you're going to get your own questions answered as well. So we would appreciate if you helped us a little bit and spread the word of what we've provided in this session and the next sessions coming up. So, all right. So this is a great question from Eric. In a completely immature organization, what's the best advice to begin to develop an architecture as you're also standing up data governance, MDM, et cetera, at the same time, you know? Can you do it all,
Um,
I think is part of the question, or can data architecture get out in front of those things? Yeah, or should it follow those things?
I think what I might try to do again, if with more detail, you might say, well, can I build again that small MVP and include MDM in that MVP, which is, it seems like one of the key components here. And, make sure that the governance process, independent of what I'm building, is able to manage that properly. Again, it's difficult to answer the question probably without more information, but I think in general, if you're building out governance and MDM, I think it's always great to have a real use case side by side with that you're also trying to develop.
So, Carlos, we just talked to a prospective client this week that asked this question. They're trying, all these different business units are kind of standing up their own data governance programs or data analytics programs, and the poor architect's trying to get out in front of them before they create silos, right? With
That's right.
standards and processes, but he knows it's got to be lightweight because he can't slow them down or they'll completely ignore them. It's tough. That's a tough place to be. So I think we're proposing that we help them develop the guiding principles, like kind of what we've set down here, and then use it as an educational tool to get out.
Yeah, I mean, the main principle here is don't make it a big effort, right? I know, a data architecture is a big thing, but don't make it big. I mean, often maybe all you need to do is use one or two new tools. If you're an immature org and you need tools, pick one or two new tools, pick good ones to build on, and then try to line that up with something that matters for everything else that's going on at the same time.
Yeah, there's different classes of tools. There's the modern data stack on one hand that's got like 1,400 different options, right, of tools that you can choose from. And of course, when you go down to that extreme, we're seeing a rebound effect where some vendors are giving you all in one, right? You buy
Right.
one tool and you get everything from A to Z, from data to analytics. And, frankly, for some organizations like the immature organization here or a smaller and mid-sized organization, those all-in-one tools, or even a business unit, part of a larger organization, those tools are perfectly fine. Like I'm thinking like of a Domo, for instance, that has everything you need. It may not have all the bells and whistles, but it covers every step in the stack, right? And it's completely integrated, easy to deploy, easy to manage. Okay, from Ram, another one from him. With tools, we may run into integration mess, and many times you'll see many overlapping capabilities. So coding may be a better option than GUI methods. Okay, I think he's responding to my question why we're moving back to coding. Yes, I mean integration mess. Yeah, the ETL, ELT, that gets
Yeah,
really complex, right?
it is. I mean, I gotta say this is personal preference, I think, right? I mean, I see a lot of people write a lot of code to do integration, and it's a mess also, right? I think regardless of whether you go the code solution or you go a tool solution, that has GUI, all the principles still matter, code management, versioning, deployment, testing, repeatability, they all matter, and if you're more comfortable and your team's more comfortable with coding, that just might be the way to go. Most companies out there, they haven't gone in any particular direction in this area when we talk to them. So often the tool with a GUI might be a better solution, but the truth is I wouldn't, if my team is really strong, or they're strong coders, I wouldn't have a problem with them doing it that way.
With code, and I'm showing my bias, is that you bury the metadata and you make it harder for the next guy to come in to understand what was done, right?
Right. Yeah. True. And I think coding, where it ends up degrading in this case is, the business rules are baked into the code.
Yeah.
And there's a lot of case statements and, other things in code that end up being, again, it's easy for a coder to bypass, maybe quote unquote, again, the right way to do it.
All right, from my friend Mike, who is a big data warehouse automation proponent. If you avoid productivity automation tools, how do you build iteratively without re-engineering and rework?
I can't say that you won't ever refactor something or rework it, but I'm really talking about if you built a good model to start with transformation taking place in the right places, I've never seen a reason to say, I've got to rework that model. Now, do I have to enhance it? Do I have to add to it? Do I have to add things to it? I do. But do I have to rework that model? I guess, I would think I wouldn't, right? If I've got a good foundation, if I've already built a good foundation.
Okay, this is a question about data model design. Need to know if a data model that has too many tables with limited columns in one table that does table joins is better than having columns in few tables. Need to understand the do's and don'ts of data model design.
Yeah, I mean, that's a hard one to answer, right? Because that's, the model might be correct, right? You could have a lot of columns in one table, and that's correct. It's really about, did you build the model correctly? Like I talked about dimensional modeling and why we see it sometimes or often not being done well. And, if I were to tell somebody what's in a fact table, but a fact table only has measures or pointers or dimensions. If I see anything else, there usually has to be a good reason for something else like that being there. On the other hand, can a fact table have pointers to 38 different dimensions and have 50 measures in it? It could. Or could it have one measure and two pointers to two dimensions? It could. And both of those would be correct designs if that's the right model.
All right, another question from Mike. You mentioned star schemas. What other model types do you suggest? Ever try Data Vault?
Yeah, I think we mentioned Data Vault on the second to last slide there as a good reason to a good model maybe for a refined zone. Data Vault's usually not typically a good way to give data to an end user, but it is it makes it, the user still wants to pivot the data and in different ways, right? And especially financial analysts and people that are analyzing resources and that sort of thing. But the data vault model is definitely it's a good concept, a good model. We see it often used in certain sectors and certain industries more often than others. It's probably used in financial and manufacturing a little bit more.
From what I've heard, it's good for managing change and
it is
high volume loading. And a lot of people build a star schema on top of it to make it easier to access.
Yeah, that's typically the model, is that the star schema allows people to see data, pivot and drill the way they want to, but the data vault allows you to, it's auditable, right? It allows you to store all the data with a particular methodology that's consistent throughout the organization. I think also, so the adoption of that is a good one if you're going to use that as like your refined zone or refine. I just don't often recommend it because most companies don't have the skills to build it or maintain it.
Yeah. Is there one type of model you tend to build more than the others, or what would be the percentage, like star schema versus data vault versus third normal form versus something else? Do you yeah, like,
yeah, in my mind, there's always a star schema involved because there's always dashboarding and the interactivity that goes on around dashboarding and Excel pivot tables. And people want to drill down and those kind of things, right? And the star schema fits perfectly well for that type of work. It also allows you to cut across the enterprise and uses conforming dimensions, which is a pretty powerful thing. So it seems like there's always a star schema needed at some point in the process. Other models, it varies. I would say a dataops model is often only used if it's the right type of client in the right situation. Like I said, it tends to be adopted a little bit more in certain certain types of industries than others. Third level form is still obviously valid for often application design, and it's still valid even if I'm creating, say, refined data that's master. Let's say I'm creating a client master data table, and I don't necessarily want to store all the master data about a client in one big 500 column table. It might make sense to make that a little third normal form type table that makes sense. So I think again. All the models are still relevant, in different ways. Most of the well-known models or data modeling techniques are still relevant. And it's up to you to use them, how you want to in the right place. And again, third normal form is a good way to store some refined data. I don't necessarily recommend all refined data to be that way, but some refined data could be that way.
Okay, I'm going to ask you two questions because I have to step out for like a minute. Anonymous asks, how can we make the sandbox environment agile in terms of timely data on hand quickly? And Lewis asks, how do you change the traditional IT mindset to move to these new analytical architectures and way of working? But why don't you address the sandbox one first,
Okay.
and I might be back by the time you answer the other one.
So I see the sandbox environment as a place that's fully controlled by the analyst or data scientist who uses that sandbox. So to make that happen, they need to be able to put data into their sandbox anytime they want, however they want. So I have data all throughout the organization. It's in sources. It might be in my raw zone. It might be in my refined zone. The data scientists can pull it into their sandbox, do what they need to do, and then hopefully produce some value out of it. As far as making it agile, I see them as working almost outside of the agile process. The sandbox is purely like a discovery area. Let's work on something that we don't know we'll find an answer to, but maybe we will. Maybe we can build a predictive model for some measure that's important to us, but I can only do that by maybe using the sandbox and determining that result, see if I can get those kinds of results. So I see the sandbox as basically not necessarily part of the iterative releasable, every 2 weeks or deployable process, but something that's happening on the side. And really it's a way so that people they'll still do this on the side. If you don't give them a sandbox, they'll try to copy it down to their laptops and work in Excel and things like that. So the idea here is to give them an environment that actually helps them work better and faster with a lot more resources, with no storage constraints or compute constraints.
I'll read the second question to you again. How do you change the traditional IT mindset to move to these new analytical architectures and way of working? Well, that can be almost impossible in some situations if you have a hardcore, old line, traditional IT organization. But
yeah, I think Wayne and I would say there are some cases where we haven't been able to do it, right? Where, we give them all the reason to do it and they don't. But if you were to ask me the best way to do it is, I would say show them what you can do with this new architecture. And if they're a leader of any kind, they'll go for it, right? They'll dive in. They love it when you show it to them.
Casey asked, the data zones look a lot like data lake constructs, but are you more referring to whatever zones we choose, be it virtualization or graph or data lake warehouse? I don't think so.
Yeah, no, I mean, I think the zones are purely labels of what, the fact that something is in a refined zone means we've cleansed it, we've done some transformation to it, maybe we've merged it with something else, maybe we've deduped it, things like that. How it's stored is completely up to you, really. It doesn't have to be stored in any type of particular model. It doesn't have to have any particular type of database. I would say it's definitely not what I would call a data lake construct either. It's really up to you to make sure it's stored the way people need to use it.
The next question is from C Dove. What is the size and content of Sprint Zero? It's interesting because we were just talking about this earlier
Yeah.
this week. Right. And what did we say? You gotta stand up the infrastructure, you gotta choose the tools, you gotta define the roles and who's gonna fulfill them, right? And you gotta prioritize the use cases and define those get the requirements for those use cases. Right?
Yep. And I don't know if I've ever actually thought about this question very well, like sprint zero, is it really a 2 week sprint, right? It's probably not. What Wayne said, everything's true. All that needs to happen in sprint zero. And I see one of the things I see a lot of times, especially when people are using new tools or using new tools in the cloud, is they're unsure about, are they configuring them properly? Are they provisioning the right things? And are they doing it properly? So that can take some time to determine, what you need and how you need it. There's so many options. That's good and bad. There's so many options that it can be difficult to know you're doing sprint zero properly.
Yeah. So there's no formal guidelines on time length.
No.
It may take some organizations 6 months, maybe, or to a year to get sprint zero done. We've seen that just standing up a cloud infrastructure can take a long time in an organization that's conflicted about which direction to go.
Yeah, there are some organizations that they want to do a comparison. Well, should we do AWS or should we do Azure, or something like that? And very often all those things definitely slow down the process.
A few more. Well, here's a comment from Christy. I need to drop off today, but thank you very much. I've been a fan of your website and blogs for all years and really appreciate all this information. I plan to be at all the webinars in this series. Yay, Christy. We can't wait to have you back. Laughed about the coding mess comment. Lewis, why do you think OLAP cubes are still a common option for analysis purpose? It's interesting no one talks about OLAP anymore.
Yeah, that's an interesting thing that he brought it up, because I almost never talk about OLAP cubes anymore. And OLAP cubes were part of every solution I built up until about 6 or 7 years ago. And here's why somebody like me is not talking about OLAP cubes anymore, is because OLAP cubes were meant to be a way to put the data into a columnar database format, a columnar storage format, and do high-speed aggregations quickly. But it required the movement of the data one more time from wherever you had it into the OLAP cube, and the OLAP cube to be built to do it. I feel with today's modern cloud architectures and cloud databases that they're also columnar database. A tool like Snowflake or Redshift and Synapse will store data in a columnar format, a storage format as well. Do you get most of the benefit out of it already? By moving it into now another construct like an OLAP cube, now you're moving the data one more time to do the same thing to it. Now, that doesn't answer the question, why are they still a common option? The reason I think is because Excel works with OLAP cubes. Excel and OLAP cubes go hand in hand. They're so tightly coupled together that if you create an OLAP cube and throw it at an Excel user, it's exactly what they need, right? So, and the interfaces and the way Excel can interact with an OLAP cube has been developed over time for a long time, and it's a way people like to work.
That is interesting. I wrote so many reports on OLAP, MOLAP, ROLAP, HOLAP, and yeah, then it just disappeared, but still being used. All right, last question, but it actually brings up a whole bunch of architectural choice questions. So Brad writes, are you seeing more organizations adopt a lakehouse architecture, Delta, Iceberg, Hootie, Hive, Acid, over purpose-built EDWs like Redshift and Snowflake? And while you're at it, Carlos, might as well talk about the data mesh and the data fabric, but talk about lake houses versus data warehouses first.
Yeah, I mean, I would say what organizations are doing is, I wouldn't say more of either or, right? There's a movement towards one and there's movements towards the other. I wouldn't say there's one that's winning or one over the other. Often they're going forward with whatever they're comfortable with already.
I mean, you and I mostly see companies with both a data warehouse, data lake house.
Yeah.
And sometimes sometimes the lake, I mean, ideally we think the lake house should feed the warehouse, but recently we saw the reverse happening.
Yeah,
And now some companies, I think the more advanced ones, are just buying lakehouse concept as Snowflake and Databricks and others are trying to combine the best of the warehouse
right.
and the data lake into one data platform. So I think we'll all end up there using these
Yeah.
open table formats at some point.
And I don't see these as mutually exclusive. Like you said, a lot of people do both, and the truth is, I think people probably need both, and maybe in the end it ends up being just one tool or one product or one platform. But I don't see one winning over the other. In fact, I kind of see the need for all of this to come together, really.
Can you map the data processing zones we talked about to these physical architectures? Like, would a data lake kind of map to the raw zone and a warehouse map to the refined and the analytic zones?
Yeah, I
Like
would say that's
Data
typically
Mart would be the analytic zone, the warehouse would be the refined and
right.
trusted zone.
That's typically the way you would do it, right? And a data lake is raw data, it's unmodeled, or you just kind of inherit the model that you had at the source. And so having a good area to process that type of data is important, especially if you're a big user of that type of data. On the other hand, once you refine data and once you create dimensional models or an analytic zone, that type of data structure, often it ends up being in traditional tables and columns, right? So tools like Snowflake or Redshift, tend to be more along those lines, while tools like Delta Lake, for example, is more kind of a raw data. They kind of came from different, they were conceived from different points in time for different purposes, but the truth is they're coming together, I think.
Yeah. So, I mean, conceivably, you when we talk about zones, we didn't talk about that. You theoretically could have your zones running on different physical systems, but you could,
Yeah,
right?
yeah. I
Now,
think that
I don't think
those,
you would recommend that, though, would you?
well, not really, but I think in general, that's one thing people should take away from this is that the zones are conceptual. That doesn't mean that's all in one database or one product or anything like that. In fact, you may have kind of a data mesh sort of situation where you have one business unit working one way and another business unit working another way, and you're working on in different technology, but under the covers, you should be kind of producing, you should conceptually be building it the right way. So one group's building refined data, another group's building refined data. They may be doing it in different databases or different places, and it maybe whatever works for them is the right way to do it.
All right, last question. Data mesh, data fabric. Now, this could be a whole session in of itself, and I have a lot of opinions, but I think the short story is that, data mesh is as much an organizational approach as it is a architectural approach. And in fact, it came out of the software engineering space, which wants to treat all data as object-oriented code. So pure data mesh, I think, is completely unworkable, but a lot of people are adapting concepts to data architecture and having some success if they're not completely befuddled. And the successful ones tend to come from organizations that are built through M&A. So there's a lot of different business units, each having their own data analytics group or operational systems group or both. And in those situations, I think a data mesh can work because you have this concept of domains with their own developers who are building not only the operational systems, but the analytical systems. And they're supposed to productize that stuff so that not only their group can consume it, which is their primary focus, but everyone else in the organization. So it's a very decentralized approach. And if you've addressed decentralized approaches, you know that the liability is integration and consistency. So if you're going to go that route, you need very rigorous, robust, centralized governance. I know Shema calls it federated governance or something. The governance is centralized. People from all across the organization get together and they come up with standards and processes and rules, and then they apply it back to their individual domains. We're finding that the data mesh is best implemented with a centralized data platform like Snowflake and as a certain set of centralized tools like dataops tools and data monitoring tools. So in the end, if you go completely decentralized, you're at high risk of data chaos. And of course, the people going that direction are completely annoyed to no end at the centralized approach, which is, the liability there is complete bureaucracy, repression, red tape, bottlenecks. So the only way to really succeed is to be federated, right? To have both centralized groups and decentralized groups that are doing their own things, but doing them in concert and working together. So you get the best of both worlds, centralized, decentralized, without any of the downsides of each, because there's significant downsides if you go one way or the other. And that's what we see companies do all the time, both organizationally, architecturally. They just flip-flop between centralized and decentralized. You do decentralized and you realize, oh, that's really painful. Too many bottlenecks. People are really unhappy. So let's go completely decentralized. And then you realize, oh man, this is just a bunch of data silos, and we don't have a real organization anymore, or a single version of data that we can trust. And they go back and forth. Federate. That's my last word. But Carlos, I'm going to give you the last word for this webinar before we shut it down. It's been a lot of fun, I must admit, but you get the last word.
Yeah, I think just to kind of add on to what you're talking about, say, for example, data mesh, I think if that's the organization, if that's the path you're going down in your organization, it's still important within those business units and those domains to do everything we talked about, build good refined data, build good data models, do transformation where it needs to be done, use the tools for the right purpose in the right way. Just because, you're working in your own business unit doesn't mean, often I think it's very appealing for business leaders to say, well, now I don't have to wait for IT to do anything. I've got it all in my business unit. I can get things done. But it's still important even for your own business unit to build things properly, because you'll be able to move much faster, much easier, make changes faster. All those things that we talked about will happen. It doesn't have to be a big IT effort to get that done.
Well, Carlos, we've spent almost an hour and a half here, but it's been a lot of fun. And I hope we answered people's questions. I learned some things, which is always a good sign. And, we're going to do this series again in the winter. So you and I will need to come think about a topic we want to drill in on. I guess I think we did the whole landscape.
Yeah,
maybe we drill in on like the zones or oversight or something like that. But that's something we can think about in the next.
Okay, no, that'd be great. That'd be awesome.
Well, thank you, everybody. I know there's still quite a few folks on the line. Thank you for all your questions and participation. We'll send you the deck. We'll send you a link to the recording. Pass it around. This is free. We want you guys to have all the information and knowledge that we've worked so hard over the years to build. We want to share that with you so you can be successful. So with that, have a great rest of your day and a great weekend.
Thanks, everyone.